Hi, in this demo we're going to explore a little bit about physics bodies and how to use physics to simulate real-world interactions. So we've got a little bit different scene. I've called it main scene, but we're loading it up the same way in the view controller. So we want to concentrate on this main scene. In our create scene, I'm just going to set the background color to a gray color. And then I'm going to set the force of gravity for the entire scene. Because when we deal with physics bodies, we deal with the bodies in motion in a physical context. So we can set various properties for the world physics. And one of those that we can set is gravity. So here, I've just defined g as negative 9.8. This is in meters per second. Remember, though, that in our coordinate system, y is increasing upward, so we make this a negative 9.8 meters per second. And then we have a multiplier here called lunar, which is the multiplier for gravity on the moon. And then I just set self.physicsworld.gravity. Remember, self is the scene, so I set the gravity in the physics world for the whole scene as a vector. Now, let's make this 0. This vector is the change in x and the change in y. So I want gravity to pull me straight down no matter what. So I'm making the change in x 0. And then the change in y, I'm just making it lunar gravity. So not negative g, but g times lunar. So there we go. The scale mode is the same thing I did before. I'm just fitting it to the size of the view. And then I add something called smiley face. Smiley face is just a ping, and in this case I'm just adding this little ping file into my texture of my node. So let's go back to that. And the smiley size, I'm making it 50 by 50. It really doesn't matter what size the underlying ping is. I can size it to anything I want. This could be a TIFF, it could be a GIF. But remember, the bigger that this gets, unless it's a vector image, I'm going to have some aliasing going on here. So I don't want to make it too big. So then I set my sprite node called Smiley, and then I initialize it with that image. So this makes things a little bit more interesting. I'm looking at an actual textured sprite now. I set my smiley size, and then I set the position to the midpoint of my scene. I name this because I may need to get to this thing within the nodes, within the tree structure. So I name it. I give it a name, Smiley. And then I set up a physics body on the node. A physics body, I can set it up very simply by just saying a physics body. And then here I'm using a class method called body with circle of radius. And I'm fudging this number a little bit. If I set it to 25, which is half of my rectangle size, then I'll have a little bit of a gap around my smiley face. So I'm just setting it with a circle of radius of 21. And then I have various physics properties that I can set on the physics body itself. Mass is specified in kilograms, and there is no default value here. Density is specified in kilograms per meter squared. And then what will happen is mass and density will adjust each other automatically. If I set mass to something else, density will adjust. If I set density to something else, mass is going to adjust. Friction is the friction of objects that come in contact with this physics body. The default, this can be a value from 0 to 1. The default is 0.2. Linear damping is the friction in a straight line due to air or fluid friction. And again, from 0 to 1, the default is 0.1. Angular damping is the same sort of thing, but it's rotational friction. How is the rotation going to be damped? Depending on the air or fluid density around it. Again, 0 to 1, and my default here is 0.1. And then finally, restitution is the bounciness of the physics body. So here, the higher the value, the more bouncy this thing is going to be. The default is 0.2, and again, my brackets are from 0 to 1. So finally, after setting these properties, and we certainly don't have to set any of these properties, we can just get the collision volume because certain of them have defaults. After setting the properties that we want to set, we just add the child to the scene. So then there we go. And at this point, it's going to drop off the bottom of the scene under lunar gravity. So let's go ahead and run and see that happen. And there we go. So under lunar gravity, it drops a lot slower than had we dropped it under Earth gravity, or G. So lunar gravity gives us a chance to see it before it drops off the bottom of the scene. Okay. Well, let's have this thing interact with some other thing. So I'm going to add a platform to this. So this is pretty simple. I'm just going to uncomment this code. And down here, I've got a method called new platform with position and size. So I'm going to make a new sprite. This is a sprite node platform. And I'm initializing it with a white color. And then size I'm just passing in. And then I'm setting the position on the platform. Now, I want to make this a physics body, but I don't want it to respond to physics actions. In other words, gravity here. So I make it a physics body the same way I made before, except this time I'm using the body with rectangle of size and passing in the size. And then I'm just setting the dynamic property of the physics body to no. What I will get here is collision, but it will not respond to the force of gravity in this case. So by setting this up, I set the position of the platform and the size of the platform, and then I make a new sprite node called platform1 with a new platform with position, with that position and size passed in. And now I will get a platform that my smiley face, as it falls, will collide with it and stop falling. So there we go. And we even see a slight bounce here. Let's do that. Let's run that again so that you can see it bounce a little bit. Concentrate on what happens at the bottom. There we go. There's a little bit of bounce. Our restitution is set fairly low. If we set restitution on the smiley to 0, it won't bounce at all. If we set it to 1, let's go ahead and do that. It's going to bounce for a long time. Now, the smiley, here we go. The smiley has a mass and a density, and this will also affect the amount of bounce, but not as much as restitution affects it directly. Okay, so let's find a nicer value for restitution. Let's say maybe 0.5. And this is really not linear. 0.5 isn't all that much more bouncy than 0.2. But 0.5 will give us a little bit of bounce. Okay, now let's change gravity just slightly. Let's vector gravity to also be just a little bit off in the x direction. So in other words, it will be some gravity pulling it to the right. So we can do that by saying that this is maybe 0.1. And then if we set our restitution back to 2, or 0.2, so that it's just as bouncy as it was before, what will happen is it will bounce slightly, and then it will begin to roll because gravity is pulling it to the right. But because there is a friction coefficient, it will actually roll rather than just slide. The physics is actually implemented very well here. I don't have to tell it to roll. We have a friction coefficient of 0.2, and therefore it will roll. Here we go. So when we get to the bottom, it begins to roll. When it rolls off the platform, it falls out of the scene. But it's still there. So let's look again at our diagnostics. We have 2 nudes and 2 draws. And now when it rolls off the platform, OneNote and OneDraw. Okay. So we're doing some more interesting things. If I rotate the platform, of course, it will roll down without this force of gravity. So there we go. Of course, if I set my gravity, my y vector and x vector to 0, I have, let's say, gravity in outer space, or gravity where space has no curve at all. So if I do that, of course, the object will not fall. And in order to get it to move at this point, we can apply forces to the object to get it to move. And that will be the subject of our next demo. Thank you very much.